Today we're going to go over the microcontroller coding, mainly posting to a database. Up first is the variables that we'll set up to make this work. We have the includes at the top, which are .h files of libraries that we'll be utilizing later. The SSID router is the Wi-Fi name. The password router is the password for the Wi-Fi. The name server is the static IP of the website we're connecting to. This will be used later to make sure whether or not the server is actually talking. The current state get and current state post, those are two different addresses for the APIs that we'll be getting and posting from. Wi-Fi client secure client is actually setting up the client to connect to the server to get and post, and the HTTP client is also another client that we'll be setting up later. These next few variables are variables that you've seen before in the last video, where we have read temp 1, read temp 2. Those are the GPI ports of the temperature sensors of where they're hooked up on the board. And then these next few variables are just variables that will add the analog reading into and then convert it back into a Fahrenheit temperature, which are the temperature 1, temperature 2, and ambient temperature. Ambient temperature is not utilized yet just because the ambient temperature sensor has not come in the mail yet, so we're waiting on that. And yes, I know what one of those variables says. You're just going to have to deal with it. This is the setup of the code. We start with serial.begin. This sets up the serial monitor. We wait a little bit before we start connection to the Wi-Fi. Wi-Fi.begin. This first sets up the connection with the Wi-Fi, and then the while loop then waits until we're connected. Once we're connected to the Wi-Fi, it prints the IP address that the Wi-Fi router gave to the ESP32. Client.setInsecure. This is a function that allows the ESP32 to blindly trust whatever connection it is getting from the website. This is because I do not have identity or AAA set up on the website yet. We may end up learning identity AAA with users and passwords, but for now, we're just blindly trusting my website. The response variable is the first connection to make sure that the website that we connect to with the server name, this is the IP address of the website that I'm connecting to. This is just to make sure that it's actually responding before I continue. And then the PID mode, this is from the previous video showing that the inputs for the read temperature. This is just setting up the GPIO ports 34 and 35 as input analog reads for later. Up next is the loop. We have commented out in the beginning. This is the code that you would need in order to get objects from a database. I'm not going to go into too much detail because it's mainly just setting up an HTTP client, getting the data, and in the connection. So in the beginning, we have set up our initial variables for analog read. Then we have a for loop that then reads the voltage across the temperature probes, and then we average them out based on the last 10 numbers it reads, and then temperature 1 variable, and temperature 2. This is then averaging it out and also dividing it by the number to convert it back to Fahrenheit. We print those, wait 20 seconds, and then after 20 seconds, just because we wanted to see if it worked, we set up our HTTP client, then we add the header. This is needed for the API object to HTTP post to the database. So the header needs to be there before we end up pushing the JSON object. Then the current state is the JSON object that we push. So we set up the necessary requirements to post to the table we want to. And then I'm also adding in the temperature 1, temperature 2, and ambient temperature for the values that we read. We print the current state to make sure it looks good. This was for debug. And then we end up posting it with HTTP post. We print that response to make sure it works. And then we shut down the HTTP client, and then we loop it back over again. After the website is turned on and the database is running, the microcontroller was powered on, and this is the output that it was able to post to the database. As you can see, the first temperature on temperature probe number 2 was reading 1000 Fahrenheit. The reason was because it was actually unplugged from the breadboard. As soon as I plugged it back in, it was reading 70 again.